Most casual homeowners firmly believe that sharpening a chainsaw simply involves blindly rubbing a generic round file against the steel until it looks visually bright again, completely unaware that this crude approach instantly ruins expensive cutting hardware. Right now, we are going to dissect the hidden physics and mathematical coordinates of chainsaw sharpening geometry, revealing the exact engineering secrets that dictate raw cutting speed and prevent catastrophic kickback accidents. First, we analyze the top plate filing angle, which is widely recognized as the definitive steering coordinate that determines how aggressively the cutter slices through horizontal wood fibers. When looking directly down at the chain from a strict bird's-eye view, this specific angle forms the sharp, diagonal cutting grade that shears the wood grains cleanly away from the log. For standard cross-cutting applications in clean softwood, global manufacturers meticulously grind this edge to a sharp 30-degree angle to optimize raw cutting velocity and chip clearance. However, when dealing with frozen timber, muddy oak, or dense hardwood, structural engineers deliberately blunt this setting down to 25 degrees to reinforce the steel edge against premature chipping. Conversely, specialized ripping chains used in custom milling operations push this geometry down to a flat 10 degrees, radically altering the physics of the tool to cleanly slice parallel along the log's longitudinal growth rings. If an operator accidentally sharpens a standard chain with mismatched top plate angles across the left and right cutters, the entire saw will immediately experience severe tracking error. This mechanical imbalance forces the bar to aggressively curve to one side during a cut, binding the chassis inside the log and causing heavy, uneven wear on the metal guide rails. The physics behind this specific angle revolve around the shearing mechanism, where a steeper angle creates a razor-sharp edge that dully degrades at an incredibly rapid rate when encountering dirty bark. Furthermore, maintaining this perfect diagonal slope requires the filing guide to be held perfectly perpendicular to the guide bar, a skill that takes professional loggers years to fully master without mechanical assistance. Modern high-speed cameras reveal that a perfectly calibrated 30-degree top plate effortlessly rolls wood fibers into elegant, curled shavings rather than generating fine, exhausting sawdust. This visual distinction between clean curls and dusty residue serves as the ultimate diagnostic test for evaluating whether your current top plate geometry is truly optimized for production. Ultimately, mastering this single spatial orientation allows your engine to maintain its peak RPM range, directly reducing thermal stress on the internal piston and minimizing total fuel consumption. Metallurgical stress testing proves that maintaining uniform top plate angles across every single link stabilizes the chain's harmonic resonance at maximum velocity. This structural stability prevents microfractures from developing along the rivets, which is the primary cause of sudden, catastrophic chain breakage under extreme tension. By consistently utilizing a precision mechanical filing jig, you guarantee that every cutting tooth presents an identical slicing plane to the wood matrix for unmatched smoothness. The second geometric coordinate is the highly debated down angle, which requires the operator to intentionally tilt the sharpening tool 10 degrees downward relative to the horizontal chassis of the chain. This complex, off-axis filing technique is specifically engineered for high-performance full chisel cutters to create a distinct, razor-sharp hook directly under the top plate cutting corner. By executing this unique downward stroke, you mathematically alter the slitting velocity of the side plate, allowing it to act as an aggressive scalpel that severs vertical wood fibers with minimal mechanical drag. Granted, this advanced setting is notorious for being incredibly difficult to maintain manually, which is why casual operators regularly skip it entirely and file perfectly flat across the bar. However, failing to incorporate this 10-degree slope into specialized professional chains severely compromises cutting efficiency, causing the tool to bounce violently inside the wooden kerf. This erratic movement triggers heavy, exhausting vibration throughout the machine body, causing rapid operator fatigue and severely stress-cracking the master chain drive links over time. When properly executed, the down angle creates a compounding wedge effect, meaning the tooth utilizes the kinetic energy of the rotating engine to pull itself deeper into the wood structure automatically. Without this subtle downward tilt, the leading edge of the cutter adopts an inefficient, blunt presentation that tends to scrape the wood surface rather than slicing beneath it cleanly. Metallurgical analysis shows that the structural steel located in this specific hook region is incredibly thin, making it highly sensitive to overheating if ground with a high-speed mechanical wheel. Therefore, hand filing with a precise 10-degree downward slope remains the gold standard among elite forestry workers who require maximum edge durability during long shifts. It is important to note that semi-edge chisel chains with rounded corners derive absolutely zero performance benefit from this technique, as their organic geometry cannot physically support the aggressive hook profile. Consciously applying this advanced spatial setting transforms your saw from a basic utility tool into a surgical cutting instrument capable of melting through massive hardwood logs. If this critical hook under the top plate becomes too aggressive due to excessive downward pressure, the metal edge will instantly roll over and dull on the very first log. Conversely, an inadequate down angle creates a negative raker geometry, forcing the operator to lean heavily on the handlebars just to get the saw to bite. Balancing this delicate dimensional alignment ensures that the side plate cuts cleanly ahead of the top plate, maintaining perfect operational fluid dynamics within the cut. Next, we must examine the engineering purpose of the gullet, which represents the deep, curved internal basin situated directly beneath the main top plate cutter. This hollow chamber acts as a critical dynamic waste management system, temporarily gathering and holding the newly created wood shavings before launching them out of the exhaust chute. During the sharpening process, a common structural error occurs when an operator fails to push the file deeply enough into this recess, causing hardened steel burrs to clog the channel. As this vital pocket gradually shrinks due to incorrect filing habits, the passing wood chips compress into a dense mass, blocking the cutter from executing its next stroke. This severe chip restriction causes intense thermal friction, rapidly blunting the premium chrome coating of the tooth and turning the guide bar a damaged, tempered blue color. To prevent this dangerous heat buildup and maintain seamless clearing physics, you must regularly use a specialized high-clearance file to lower the gullet floor back to factory specifications. An over-filed, excessively deep gullet structurally weakens the base of the tooth, creating a dangerous mechanical weak point that can cause the entire cutter to snap off under heavy load. When a tooth breaks at 14,000 RPM, it turns into a high-velocity piece of shrapnel that can easily breach the plastic guard housing and cause severe operator injury. The aerodynamic design of a perfect gullet actually utilizes the high-speed air currents generated by the saw's spinning sprocket to continuously vacuum wood debris out of the working area. If you observe closely, a clean, unobstructed gullet allows the chain to maintain its speed even when the guide bar is completely buried inside a massive old-growth tree trunk. In contrast, a choked gullet forces the engine to labor heavily, causing the centrifugal clutch to slip continuously and forcing you to pull the saw out to clear the jam manually. Regularly maintaining this internal curve ensures that your chain operates with absolute mechanical fluid dynamics, keeping the cutting path completely clear of choking debris. When a gullet is properly maintained, the escaping wood chips exhibit a uniform, volumetric geometry that perfectly matches the physical dimensions of the cutting tooth. Micro-debris analysis proves that a choked gullet forces the wood particles to ray-cut into micro-dust, which bypasses the air filter and accelerates internal engine wear. By keeping this radius clean and polished, you actively minimize mechanical resistance, allowing the chain to flow effortlessly around the bar nose sprocket. The fourth and most critical mechanical component is the depth gauge, which ordinary users mistakenly call the rider, or safety bump position directly in front of the cutting corner. This solid steel tooth acts as an unyielding physical regulator, determining exactly how deep the following cutting edge can bite into the wood during a high-speed rotation. As you repeatedly sharpen the main cutter over months of heavy labor, its overall height naturally decreases, which systematically locks the cutting edge behind the level of the depth gauge. If you completely neglect to modify this relationship using a specialized flat file, the cutter will slide uselessly across the log without generating a single wood chip. This zero-chip friction generates immense heat, baking the guide bar oil instantly and rendering the entire machine completely useless despite having a perfectly sharp edge. Conversely, if you aggressively shave this gauge down to low, the cutter will violently gorge into the timber, drawing far more wood than the engine can physically process. This massive overload causes immediate engine stalling, snaps master chain links under intense shock loads, and regularly triggers catastrophic, life-threatening kickback accidents. To tune this component safely, professional loggers utilize a specialized drop center depth gauge tool, which measures the precise height differential down to the thousandth of an inch. For softwoods, a standard drop of 0.025 inches is ideal, whereas hardcore professionals tuning for hard or frozen would prefer a tighter 0.020-inch clearance. The profile of the depth gauge must also be manually rounded after filing, as a sharp, square leading edge will snag violently on wood fibers instead of gliding smoothly over them. This progressive rounding technique is vital for maintaining a smooth, predictable feed rate that keeps the chain tracking straight without sudden, dangerous jerking motions. Never underestimate this silent regulator, because the depth gauge alone dictates whether your chainsaw cuts like a dream or turns into a highly unpredictable liability. Advanced dynamic testing shows that a square, unrounded depth gauge transfers immense shock forces directly into the operator's wrists and forearms. This continuous physical stress can eventually lead to long-term neurological damage, commonly known in the industry as white finger vibration syndrome. Therefore, precisely matching your depth gauge profile to your specific wood type is the single most critical step in professional chain calibration. Now you hold the complete geometric blueprint required to precisely calibrate your chainsaw cutters, unlocking maximum production speeds while fully protecting your physical safety in the woods. Make sure to drop a detailed comment down below stating exactly what angle you file your primary work saw at and whether you prefer manual round files or mechanical grinding stations. Subscribe to the channel for more raw technical breakdowns of industrial logging tools, chainsaw modifications, and professional outdoor power equipment. Your phenomenal active support allows us to continue producing deep dive engineering guides, so please smash that like button and share this structural analysis with fellow woodworkers. Thank you for staying tuned through this entire technical breakdown. Never force a dull chain through a piece of timber, and we will see you in the next mechanical dissection. By sharing your personal sharpening setups and experiences in the comments, you help create a valuable repository of knowledge for the entire global woodcutting community. Our upcoming videos will dive deep into specialized carburetor tuning and advanced porting techniques designed to extract maximum horsepower from factory engines. Remember to always wear comprehensive protective gear, including ballistic chaps and full face shields, whenever operating high-performance modified cutting systems. Understanding the micro-engineering of your tools not only increases your daily output but directly ensures that you return home safely at the end of every hard day. We closely monitor your feedback to determine which technical components to tear down next, so keep your suggestions flowing in the Community tab. Keep your angles precise, keep your depth gauges perfectly tuned, and always respect the tremendous power spinning on your guide bar. Stay safe on the job site. Never compromise on your maintenance routine, and look out for our next deep dive engineering breakdown dropping early next week.